Good day, everyone. This is your unassuming tutor. Welcome to another tutoring session. The topic for the day is matrices, and today we will be learning how to find the determinant of a 3 by 3 matrix using the Laplace expansion method. Some of you may know this as the cofactor expansion method. Now, to do this or to carry out this procedure, there are 4 steps that we're going to be using. The steps are: 1, we're going to find the minors for the first row of the matrix. The second step will see us converting the minors into cofactors. The third step, we're going to multiply each cofactor by the elements in the first row of the original matrix, matrix A. And then finally, we're going to add the products. Please note, these steps can be condensed so the process doesn't seem as long. This being a tutorial video, however, I won't compact them, but in future example videos, I'll be doing just that. So let's go. We're going to be working with this matrix. We call this matrix matrix A. So this is matrix A, and matrix A is a 3 by 3 matrix where we have the elements 3, 1, 1, 1, minus 1, 1, 2, 3, and 1. So we're going to go ahead, we're going to apply the first step. The first step says we are supposed to convert to a matrix of minors. Now recall that to convert to a matrix of minor, we're going to take the first element that's in the row 3. We are then going to ignore or avoid all the elements that are in the row with that chosen element. We are also going to ignore all the elements in the column with that element, and we are left with a 2 by 2 matrix. So we're going to write this down: 2 by 2 matrix, so that's minus 1, 1, 3, 1. We're going to do this for the second element, so we can get rid of this here. So we are now at our second element. The second element is 1, and if we ignore everything that's in the row with that and in the column, we are left with a 2 by 2 matrix, and that 2 by 2 matrix is 1, 2, 1, 1. We're also going to do that for the third element within that row. That 2 is a 1. We are going to ignore everything in the row and the column with that 1, and we are left with a 2 by 2 matrix: 1, minus 1, 2, 3. We are now going to find the determinant of these 3 matrices. Now recall, to find the determinant of a matrix, we are going to multiply the diagonals. So that is A times D minus B times C. Now let's multiply. We are going to be left with here minus 1, minus 3, 1, minus 2, and this one is going to give us 3 plus 2. What are we left with? We get a minus 4, minus 1, 5. So this is now the minors for the first row of our matrix. We are then going to convert the minors into cofactors. Now to do this, we're just simply going to apply a plus, minus, and a plus sign at the top. And when we apply that, we end up with minus 4 plus 1 plus 5. Now that we found the cofactors, we can then move on into step 3. Now step 3 says we're going to take the elements of the first row of our original matrix. So we're going to be looking at the numbers 3, 1, minus 1, and then we're going to multiply them with their respective elements. So we're going to multiply this 4 by 3. We're going to also multiply those with their respective elements. So when we multiply, we end up with 3 times a minus 4, that's minus 12. 1 times 1, that's 1. 1 times 5, that's 5. Now, minus 12 plus 1 plus 5 is going to leave us with a minus 6. This minus 6 is the determinant of our 3 by 3 matrix. Again, the process is a little bit drawn out. I have expanded the steps so that we can clearly see what transpired. However, in future videos, I will be condensing these steps. Now, just a bit of additional information. The determinant could have also been found by applying this procedure to any row or column, meaning we could have applied this procedure to the first column if we so desired. We could have applied it to the second row if we had desired. So any given row or column, we could have applied the Laplace expansion method, and just the same, it would have given us that determinant. That now takes us to the end of this lesson. I hope this was beneficial to you. If you liked what I had to say, go ahead and like the video. I appreciate anything you have to say, so you can comment as well. I will be doing other videos in this series, so if you do not want to miss any of them, you should subscribe if you have not yet done so. Have yourself a pleasant good evening.